Hello students, how are you all? Welcome back to Akshar IT Foundation classes. I am your chemistry faculty S. Mohan. Students, in the ninth class, right? So ninth IIT we started the chemical kinetics, and in that we completed the first synopsis, right? So in the first synopsis we discussed what is the rate of reaction, and for fast reactions, slow reactions, okay, moderate reactions. So these all we discuss, right? So now today we are going to the second synopsis of chemical kinetics, in which we are going to study about Arrhenius theory, collision theory, and some other theories also we are going to discuss. Okay, so students, here the first topic is collision theory. Okay, chalo. Now you say, what is the collision? Collision, right? So the billiards games, no? So when you hit one ball, so this one ball is going and hitting to the other ball. So that is called a collision. Okay, collision means what? Hitting with each other, right? Chalo. So students, we are discussing about the chemical reactions, because in the chemistry we normally discuss about the chemical reactions. Okay, so the chemical reactions, how the chemical reactions takes place. So you know that some reactants will be there. Reactants will combine, react with each other to form the products. Correct? So what is the reaction here? Reactants are there. For example, hydrogen react with oxygen to form water. Hydrogen react with chlorine to form hydrogen chloride. Nitrogen react with hydrogen to form ammonia. So here these molecules are colliding. Okay, means reacting actually. Okay, reacting. So reactants are reacting to form the product. This you know. But what is actually reaction means what? Actually, what means reaction? Means reacting means what? So students, here, according to the collision theory, the reacting is nothing but a colliding the atoms. Colliding the atoms. Okay, so reactant atoms collide with each other to form the product. Right? So that is colliding. Reacting is what? Colliding. Remember that. Okay. For example, you see here, hydrogen react with the chlorine to form the hydrogen chloride. Let's imagine this is one reaction. Otherwise, we take one reaction like one A molecule reacting with B molecule to form some C molecule. Let's imagine in that way. Okay. So reactant means what? The substance which are reacting or which are participating in the chemical reaction are called reactants. And after the reaction, what is a new substance is formed? That's called as a product. Okay. So now, for example, here you see students, here I am taking one substance called A, and this A is reacting with the B. Okay. So this is forming the product C. That is forming the product C. This is one chemical reaction. Just imagine, this is one chemical reaction. So A is reacting with B to form a product C, right? But now reacting means what here? What is meant by the reacting? So reacting is nothing but here A molecule or A atom is colliding. This is A is colliding with the B. Okay, it's colliding. Colliding means what? Okay, like this, they are colliding with each other. When they are colliding, then they both combine to form the new product called as a C. Clear? So here reacting means what? They are colliding. Colliding means what? Understood? No? Chalo. So here see collision theory of rate reaction. So very important points here. A chemical reaction takes place due to the collision among the molecules. Okay. How the chemical reaction takes place? So the reactant molecules collide with each other. Okay. They collide with each other. So that the product will form. So a chemical reaction takes place due to the collisions among the molecules. Understood? No? So reactant molecules are colliding. Right. Now, the number of collisions taking place per second per unit volume of the reactant mixture is known as a collision frequency. This is very important. What is the collision frequency? So how many number of molecules are colliding, okay, in unit time? How many number of molecules are colliding with each other in unit time? Okay, that is called collision frequency. Okay, so the rate of reaction is depending on this collision frequency. How many number of collisions are taking place between the molecules. So the number of collisions taking place per second per unit volume of the reaction mixture is known as a collision frequency, and collision frequency is denoted by the letter Z. Okay. In the next term, we have one equation. So there will be a derivations also there, but we are not going to discuss about the derivation, students. So just we are going to discuss only formula, okay, and this concept, right? So now, understood? Now the value of collision frequency is very high, in the order of 10 to the power of 5 to 10 to the power of 28 in the binary collisions. Binary means what? 2. Okay. So it consists of only 2 atoms, okay, 2 molecules. So that's called a binary. So the binary collision, so the value of collision frequency is how much? 10 to the power of 25 to 10 to the power of 28. 10 to the power of 25 means what? 10 means 1 beside 25 zeros. 10 to the power of 25 means what? 10 into 10 into 10 into like this. Tens will be multiplied for 25 times, right? So then what will get 1 beside 25 zeros? So very huge number, very big number, right? So here the collision frequency will be very big number, so very large number of collisions will be taking place. So collision frequency is broader in the order of 10 to the power of 25 to 10 to the power of 28 collisions. Okay, so that is it. Now every collision does not bring the chemical change. This is a very, very important, students. Okay, for example, okay, for example, I am taking some 100 molecules, okay, 100 molecules of A and 100 molecules of B, okay, 100 molecules of A, 100 molecules of B, I am making to react with each other. I am making to react this 100 molecules of A with the 100 molecules of B. Now, whether this 100 molecules of A react with 100 molecules of B? No. Okay. So, definitely no. Right. So, 100 molecules of A cannot make 100 collisions and to make the product. So, we cannot get, so here A1A is combining with 1B to form a 1C. So, 100 molecules of A are reacting with 100 molecules of B to form a 100 molecules of C. Naturally, theoretically, yes, okay, because one A molecule is colliding or reacting with one B molecule, it's forming one C. One A, one B are combining to form one C. Now I am providing how many molecules? 100 A molecules, 100 B molecules. These 100 AB are combining, so that how many molecules we should get? We should get 100 C molecules, correct? But actually 100 C molecules will not get, okay, because here the number of collisions, okay, the total how many molecules are there, that many collisions will not take place. Even they collide, the same number of products will not okay, gives rise. Is this clear to you, Miss Pond? So every collision does not bring the chemical change. Means what? Here 100 A molecules are colliding with 100 B molecules, but we don't get the 100 C molecules, right? So means what? All collisions are not giving the product, right? These collisions that actually produces the products are effective collisions. Okay, the collisions that do not form the product are called ineffective collisions. So here, students, here 100 A molecules are combining, means reacting or colliding with the 100 B molecules. But in that, how many products, how many C molecules are forming? C is a product. How many C molecules will be forming? Maybe 5, maybe 10, maybe 20. Okay, so maybe 10 or 20 C products, C molecules are forming. That is product. Here 100 A molecules, 100 B molecules are colliding, but not 100 C molecules are not forming. Only 10 or 20 C molecules are forming. So such collisions are called effective collisions. What they are called? Effective collisions. And remaining here 20 collisions means 20 C molecules forming. Remaining how many? 100 out of 100. So 20 lost, so 80. These remaining collisions which are there, they are called as ineffective collisions. What they are called? Ineffective collisions. Why? Because they are not forming the product. They are not forming the C here, right? So that is most important. Okay. So the collisions that do not form the product are ineffective collisions. Means what? molecules just collide, okay, and disperse in different directions with the different velocities, just colliding, but they are not, okay, forming the product. Clear to you? So, here for a collision to be effective, energy barrier and orientation barrier to be cleared. Okay. So, here see students, here for simple example I will explain you. For example, you see in your class 25 members, 30 members are there, right? So, 30 members are there, 30 members will write the exams, right? So, does all the students get the full marks, highest marks? No, only 1 or 2 students out of 30 will score 100 out of 100 or 99 out of 100, right? Remaining are not cannot score that many marks, right? So, why? Because that students who are scoring 99 or who are standing at top position, so is having some qualities, yes or no? So, is having some qualities, he is showing some extra effort to score the marks, yes or no? So, that's the reason, means he may be studying more, he may be writing more, he may be some, okay, what do you say, some different way is having some, his own strategies, according to strategies he is working, and okay, so he is scoring, right? So, here also, here all collisions are not effective collisions, means what? All collisions are not giving the products. Only few collisions are giving the product, but remaining collisions are not giving the products. So, the collisions which are giving the product are called effective collisions. Okay. So, why there are only those effective collisions, only few effective collisions only taking place? For that, okay, the two factors are there. One is a factor called energy barrier. What is the first one? Energy barrier. And the second one is called orientation barrier. What is that? Orientation barrier. Okay. So, now we will discuss about the energy barrier and the orientation barrier. Okay. Now, is there any doubt in this collision theory? Very simple. So, in own words, how can you say? So, chemical reactions takes place due to the collisions of the molecules, right? And all the molecules, when they collide, all molecules cannot form the products. Only a few molecules can form, means a few collisions only can form the product. Those collisions are called effective collisions, which some remaining, they may collide, but they do not form the product. So, such collisions are called ineffective collisions. So, why those few only are forming the effective collisions? Because they might have cleared the energy barrier and orientation barrier. So, that's the reason. That's all. Very collision theory is very simple, no? Right? Chalo. Now, let's come to the energy barrier. So, students, here what this means, the energy barrier? Energy barrier means what? So, energy barrier means what? For example, students, here under normal conditions, when the molecules, okay, when making to react with each other, they have a less amount of energy. They have less amount of energy. So, this energy may not be sufficient to form the product. This energy, every molecule has some certain amount of energy, right? Under these conditions, when two molecules are colliding with each other, then the amount of energy, okay, so may not be sufficient to form the product, right? So, to form a product, okay, to make the collision effective, okay, it requires some more amount of energy. It requires some more amount of energy, right? So, it requires some more amount of energy, right? For example, you see here, here we'll take one graph here, okay. So, here for example, let us take this is an energy, okay. This y-axis I am representing the energy. Now, here there is a molecules like reactant molecules, okay. These are the reactant molecules. So, the reactant molecules having this much of amount of energy, okay. So, you can write some, okay, energy like anything. You can take 1 kilojoule, 2 kilojoule, 3 kilojoule, 4 kilojoule, 5 kilojoule. Like this, you can take some, okay, energy, some certain amount of energy, right. So, here the molecule, the reactant molecules have this amount of energy, okay. So, here to form a product, that molecule requires certain amount of energy. The minimum energy required, okay, to form the product is called a threshold energy. Okay, here it is given here. The minimum amount of energy which the colliding molecule must possess to make the chemical reaction to occur is known as threshold energy. Means what? Every molecule should have certain amount of energy. Okay, if that molecule has that amount of energy, then the collisions made that at that energy gives a product. Okay, so that collision gives a product. Means what? Certain amount of energy is required. Less than that amount of energy, if it is there, no collision takes place. Even the collision takes place, the product may not form. Okay, so here now to form a product, to make the effective collision, so for example, you think it requires certain amount of energy. Okay, so certain amount of energy like this. Okay, certain amount of energy. So this is called this. Okay, this much energy. Actually, the energy is how much it is present in the molecule, reactant molecule, this much. But to take the to make the effective collision, this amount of energy is required. Okay, so when the molecules having this amount of energy collide with each other, that makes the product. That makes the effective collision. Okay, then we can get the product here. Clear to you? Okay, so this is so what is the minimum energy required? What is the minimum energy required to make a effective collision? That energy is called threshold energy. What is called? Threshold energy. Something energy is required. Yes or no? For example, if you want to go to 10th class, okay, then you need to clear the 9th class. Okay, so when you clear the 9th class, then only you can go to the 10th class. If a student is completing 8th class and he wants to go to 10th class, is it possible? No, because certain amount of energy is required. Then certain amount of certain qualification is required to write the 10th exams, right? So here he has to pass, he has to clear the 9th class, then only he can reach to the 10th class, right? So here also for effective collision, certain amount of energy, okay, is required. When that amount of energy is there, then only that collision becomes an effective collision. If less than that amount of energy is there, even they collide with each other, that do not give the product C. Clear to you? So that energy is called the threshold energy. So here the minimum amount of energy which the colliding molecule must possess, to make the chemical reaction, okay, to occur. Make the chemical reaction is what? To make the effective collision. So that is called the threshold energy. Is this clear to you? So that is the threshold energy. Alright. So here there is an energy barrier for each reaction. So for every reaction there should be a certain amount of energy barrier. Means what? Energy, minimum energy required. Okay. So the reactant species must provide it with sufficient amount of energy to cross the energy barrier. Okay. So see now, the minimum amount of energy required by the reactant molecule to participate in the chemical reaction is called activation energy. This is a very important point. That's called what? Activation energy. Every molecule to participate in the chemical reaction to form a product, it requires certain amount of energy. That amount of energy is called activation energy. What it's called? Activation energy. Okay. Now, how can you get the activation energy here? Activation energy is equal to threshold energy minus kinetic average energy of the molecule. So, threshold energy is what? That minimum energy required, how much it is there, minus whatever the actual energy possessed by the molecules, that difference is called the activation energy. Clear to you? Any doubt? Energy barrier? So, once again here, just now I told you that all collisions do not make the effective collision. Why? Because to make an effective collision, certain amount of energy is required. Okay. So, what is the minimum amount of energy required, okay, to the molecules to make the chemical reaction? That energy is called threshold energy, right? So, the difference of, threshold energy. So, already molecule has certain amount of energy, okay. Now, to reach that threshold energy, it requires certain amount of energy is required. That amount of energy is called activation energy. Okay, means for example, you see here threshold energy, for example, it requires 5 kilojoules. Now the molecule has 1 kilojoule of energy, right? So threshold energy is what? 5 kilojoules of energy. At 5 kilojoules of energy, the reaction, okay, will be taking place. But molecular has how much? Only 1 kilojoule. So how much more energy is required? 4 kilojoules of energy is required, right? So activation energy is 4. Okay, threshold energy, that okay, energy required minus whatever the energy it possesses, that is called activation energy. Clear to you? Okay, so every molecule get okay, possess or it takes a certain amount of activation energy, then it can be able to make the effective collision. Clear, students? So that's about the energy barrier. Clear? Now, so orientation barrier is what? Orientation barrier means what? Now that energy barrier, that is one reason. Orientation barrier means what? For example, you see, there is one molecule here. This is one molecule called A2. This is, for example, A2. Okay. This is another molecule called B2. Okay, B2. Now, these both will combine, okay, these both will combine to form the product, okay. So, AB will combine to form the product. Clear to you? Now, what happens is, students, here, when this both comes like this, then what happens here? AB, these both are colliding and these both are colliding. Now, it forms a product, okay. So, here AB, AB. So, AB, AB. So, AB, AB, like this a product will be forming. Okay. Now, for example, these A molecules, instead of like this, if A molecules are coming like this, see, now it is vertical. Now, see, I am turning like this. Now, the molecule is oriented like this. Oriented means what? Changing the direction. So, now A molecule is like this. Now, B molecule also oriented. Okay. So, instead of like this, now it turned like this. So, now like this is a B molecule. Now, how many collisions will take place now? Only this A is colliding with only this B, but this A is not colliding with that B. Is that colliding with B? It's not colliding with B. Okay. So, but here you see two collisions, AB, AB. Okay. Two collisions are taking place, but here it's taking only one collision, right? Here it's taking only one collision, AB, between these two. But this A and this B are not colliding. Is this clear to you, students? Okay. Now, see here. Energy alone does not determine the effectiveness of the collision. Only energy barrier is not sufficient. Okay, I told you that two factors are there. One is energy barrier and second is called orientation barrier. Okay, the reacting molecules must collide in proper manner in order to occur the reaction. So, they should collide in a proper order. Okay, in proper order. If they collide, then only the reaction takes place. Okay. So, if there is no particular order, no proper order, then the effective collisions not takes place. Okay. So, see here now properly oriented collision means what? See, A to B, A to B. So, both are perfectly ordered. This is A, B, A, B. Okay. But here you see improperly oriented. Improperly oriented means what? Only one A is facing the one B. If the collision takes place between only these two, but these both are not colliding. Correct? So, this is okay. So, this is a properly oriented. Clear? Now, this gives a proper okay collisions will be taking place and proper products will be formed here. Right? Now, here you see during the formation how the reaction will be taking place. See here, students, here does not reaction takes place because here steps you see. Here, this is A2 molecule means what? A is already combined with A. The meaning is what? There is one bond between A and A, right? And this is B. It's combining with the B molecules of B and B. There is also bond between these two. Okay. Now, to form a bond between A and B, first what should happen? First, the bond should be broken between A and A and B and B, right? So, first the bond should be broken, okay, between A and A and B and B. So, here bond breaking and bond formation. So, here first between these two, the bond breaks here, okay. Here the bond is breaking here, okay. Here also the bond will break, here also bond will break. So, this becomes now individual, A gets separated, okay. Here B gets separated. Now, after separating, this A combined with B, this A combined with B. So this is the formation of the effective collision. Clear? Any doubt? So this simple, no? So orientation barrier, very important. Energy is not only to determine the effectiveness of collision, the reacting molecules must collide in proper manner to form the reaction. Okay? So this is an example for this. Right? So, and in the formation, first the bond should be broken between these two. Here also bond should be broken. Then they become individual. Now this both will react and form the product AB. Clear? So that is about the orientation barrier. Any doubts? Now the rate of reaction, this is already discussed in the first synopsis, that is minus dx by dt, that is equal to z. What is z? Just what I told you. Forgot what is it? Collision frequency, right? So that's called what? Collision frequency. And what is F? The fraction of molecules undergoing the active collisions. How many molecules are undergoing active collisions? Okay. So this is about the orientation barrier and energy barrier, on which rate of reaction depends. Right? Okay. Now see here Arrhenius equation. So here Arrhenius given one equation. Okay. So to explain the rate of reaction, on which factor that depends. So here this reaction, students, here we are not going to discuss in detail, because you need some basic knowledge about the logarithms. Okay, so I am going to directly, so here you can see Arrhenius given that equation K, that's called rate constant, is directly proportional to the e to the power of minus activation energy by RT. EM is what? Activation energy by RT, right? So here when you remove this proportionality constant, we get one constant that you know. Okay, this is A. So K is equal to A into e to the power of minus EA by RT. This is an equation you have to remember. So here another format is also the reaction modified Arrhenius equation. How can you do? Just you know about the logarithms. Okay, so there is a logarithm, one type of functions you can see in the mathematics. So I think in the CBSE 9th class still you can't, you do not have the logarithms. Okay, so that's what I'm not going to explain about the detailing. So very simple but very easy here. Okay, so we are the same reaction we are taking, this reaction here we are taking log, natural log on both the sides. Means what? We are taking natural log. This is called natural log on both sides. So then what happens? Log K both sides. Then it becomes log of a bracket A E to the power of e to the power of a by RT, right? So here you see, students, here this see, it's not required for your IIT foundation, but I'm telling just a little faster, so you try to understand. Here we have one formula that log AB is equal to log A plus log B. This is one formula is there. Okay, so here we are applying the log, then what happens? This is log and this becomes A in the place of A, this total becomes B. So then it becomes what? Log A plus log B. So we can write log A, so log A plus log B, so log B over. Now again we have a one formula that log A to the power of B is equal to B log A. Okay, log B to the power of, log A to the power of B is equal to this B come here and B log A. So here you can see here the power is what? Minus EA by RT. So then what it becomes? This this remains same. This is coming here. So this becomes minus ART into log E, because E is E. But log E we taken as a 1 is equal to what? 1. So 1 into something is something. So we can write log K is equal to log A minus this total becomes EA by RT. Right? Now log this natural logs we are converting into the normal logs. So then it becomes what? Log K is equal to log A minus EA by RT. So when you are converting, it becomes 2.303. Okay. So this is actually final equation, but this is all not required for you. Okay. And even main IIT JEE means also you may not get the questions like based on the derivations to derive or something. So directly just you need to remember the formula. So that is called the Arrhenius equation. Clear, students? Now next come to the transition theory. The transition theory is nothing but a transition state theory. Transition state theory, what happens here? The collisions, generally when the collision takes place, when the chemical reaction is taking place, so it cannot form the direct product. When the reactants are reacting with each other to form the product, directly the product cannot form. So you can see here, for example, these are the reactants. Can you see here? The reactants. And reactants are forming the products. You can see here, these are product. So when the reactants are forming the product, it passing through this path. It is passing through this path, right? They are passing through this path, right? So now what happens here? The reactant molecules, when they are passing through this path, then here at this place, at this place, whenever the reactants when at this place when react, this forms a complex. Complex means what? A new substance, which is called as a complex. So that is called activated complex, is formed at this stage. These activated complex later, based on the conditions, they can converted into the products, or sometimes they cannot be converted to product, but they can be converted again into the reactants. Anything can happen here. So here reactants are combining to form the product, that we know. But internally what happens? Internally, when these reactants achieve this stage, means highest energy stage, then what happens there? They form the activated complex. What it forms? Activated complex. So this activated complex, so here, so a collision between the high energy molecules. Here, high energy molecule, this is the reactant, only this much energy, but you can see the graph, you see this is at a high energy. Here at this place, the molecules possess the highest energy. So high energy molecules overcome the repulsion and brings the formation of unstable molecule cluster, which is called as a activated complex. So these reactants, when they possess high energy, then so they forms a new substance called as a new cluster called as a activated complex. But these activated complex are unstable. What are they? Unstable means they are not stable. So due to that, what happens? They can break again into the products, or sometimes it may direct again into the reactant. So here you can see here. So here you see the lifespan of the activated complex is very small, very small. So thus the activated complex breaks either into reactants again or breaks into the new products. So this activated complex, what you have formed here, they based on the condition, they may form the products, or sometimes they may again convert into the reactants. And this activation energy depends upon the nature of the chemical bonds. Nature of the chemical bonds. What are the chemical bonds? Just I told you, So here, see here between the A and A bond is present, and here B and B, some bond is present. So the bond should be broken first, they become individual, then the bonds are formed. So that depends on the nature of the bonds, in the molecules, right? And these reactions may be exothermic or endothermic. Already we discussed that exothermic and endothermic, in which the energy is released or energy is gained. And the activation energy is low for the fraction of effective collisions will be large and reaction fast. So that is about the activated complex theory. Students. So this is activate transition state theory. Now last and final one, demerits of collision theory. Just now we discussed about the collision theory. Collision theory is what? The molecules of the reactants collide with each other to form the product. But all collisions are not fruitful or not effective collisions. Only few collisions are fruitful, means what? Effective collisions, meaning or not. So here to make the effective collisions, they require certain amount of energy, which is called the threshold energy. The energy gap between the threshold energy and their actual energy is called activation energy. These things already we learned. So now in the theory, what are the drawbacks are there? So in much more drawbacks are not there, students. Here only few drawbacks we can see here. One is the theory is applicable for the simple gaseous reactions and the solutions of simple molecules. So, it is applicable only for the simple molecules, okay, not for the complex molecules. It is what explains about the only simple molecules, okay, and it is valid only for the bimolecular reactions. Bimolecular, bi means what? Two, okay, when the two molecules are combining to form the product. So, it is mainly applicable for the bimolecular, and it is not gives the exact value for the complex molecule. Complex means what? Many, okay, many molecules are involved, then it will not give the, okay, perfect calculation, okay. Next, it does not consider energy taking or breaking the formation of bonds, okay, and the most important is that the rate of decomposition of hydrogen iodide and a nitrogen dinitrogen pentoxide at the same temperature, okay, and concentration are equal according to the collision theory. According to the collision theory, okay, according to the collision theory, the rate of decomposition is what? Splitting. The rate of decomposition, okay, at the same temperature, okay, are equal, but this is according to collision theory, but practically they are different. Means what? So here there are few drawbacks are there. The collision theory is mainly applicable for the, okay, simple molecules, okay. Remember that it's applicable only for the simple molecules. It's not applicable for the complex molecules, okay. So that is about the, okay, demerits of collision theory, right, students? Okay. Now next, so next here the practice sheet is there. So let's see the practice sheet here. So what we discussed in this topic, here we have some questions. So sessions here in this chapter, don't go into the derivation part and much more calculation part, because we are only in the 9th class. So such high calculations are not required. So such high derivations are not required. Only mainly concentrate on the theory concept, okay. Chalo, see now, the excess of energy required for the reactant molecules to undergo a reaction is called what? Activation energy. Just now I told you, activation energy. So the answer is, okay, 4. In Arrhenius equation, the fraction of effective collisions are given by, this is total equation, fraction of effective collision is this one, okay, that is E to the power of minus A by RT. Next, the threshold energy of a chemical energy of a reaction depends on nature of the reacting substance, right? Activation energy is to rate of reaction, directly proportional and inversely proportional. This is inversely proportional. So, right? Then come to the rate of reaction can be increased in general by all the factors except using catalyst, using temperature, increasing the activation energy, okay. This answer. The minimum amount of energy required for reacting molecules, okay, to undergo the reaction is called activation energy. Increase the concentration of the reactant leads to the change of collision energy. Energy of activation of an exothermic reaction. Energy of the activation of exothermic, that depends, we cannot predict it, okay. The chemical reaction in the reactants require high amount of energy of activation or generally slow reactions, okay. The rate of reaction increases when the temperature increases, because the increase in the number of collisions, okay. So these are the just theoretical questions of the concept based questions. So students practice on this concept based questions perfectly, okay. So with this we stop for today. So we completed second synopsis, and in your 9th class IIT syllabus we have only one more synopsis of the chemical kinetics, okay. And remaining, actually it's a very big topic, but it will be covered in the next classes, next higher classes, right. So students, let's stop with this one and take care.